This is CPM Precalculus, Chapter 2, number 17. So here we're continuing on, and most of us are comfortable with shifting parent graphs as we did in the previous problems on grids A and B. But the question is, do piecewise functions have the same properties when you shift them? So we're given a piecewise function. Here's f of x, and the two pieces of f of x are x squared and x plus 2. Okay? So part A is to sketch the graph of f of x on grid C. And recall that you can use your calculator to verify your graph is correct. So let's go ahead and sketch this. Here's grid C. So we can graph x squared, right? X squared is just our parabola, right? And it's going to start at 0, 0 here at the vertex. Go up to 1, 1, right? I'm just getting some points. Negative 1, comma 1, negative 2, comma 4, because negative 2 squared is 4. Negative 3, comma 9, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be all the way up here off the chart. On the right, it's going to be 2, comma 4 again, right? I'm going to make this an open circle. I'm making that an open circle at 2 because we're only graphing the x squared for x is less than 2. So we're going to graph it starting at x is less than 2 there and to the left, right? So this is where we're graphing x squared. Okay? So let me go ahead and connect these dots. So here is a picture of our parabola, and it's going up to the left forever, up and to the left here, so it's going up and to the left forever, right? But then here it stops at 2, right? And 2, it's an open circle again because here x is less than 2 is where we're defining x squared piece. Okay? Now, x is greater than or equal to 2, right? That's where we're going to start at 2 and go to the right, right? So now that is going to be x plus 2. So to graph x plus 2, that's just y is equal to x plus 2, right? So that's basically going to be starting at 2 and having the slope of 1. So starting to 2, right? That's our y-intercept. And going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and so on, right? So this is going to be our graph here. And I'm going to close this circle here because that's part of x plus 2, and that's when x is greater than or equal to 2, okay? And I'm not drawing it to the left because remember we kind of talked about before, but there's like a fence here, right? That's where the transition happens. Okay, but I don't need to draw on the fence, but right now I know transition at x is equal to 2. So let's go ahead and verify this with our calculator. So let's bring out our calculator. Okay, go into y equals, clear anything that's there. And to verify this in our calculator, remember, we plot the first piece, which is x squared, in parentheses. So I say x squared in parentheses. Right next to that parentheses, I open a new parentheses and I say x is less than 2. So I go x, to get to less than, I go second math to get to the test. Less than is number 5, 2. So that's the first part of my function here. It's the first piece, x squared, for x is less than 2. Okay? So then I want to put the second piece in here, x plus 2 for x is greater than or equal to 2. So then I say plus, I add the second part in parentheses. So open the parentheses and say x plus 2. Close the parentheses. Open it again and say this piece's domain. X is greater than or equal to 2. So I go, again, second math to get to the test menu. Greater than or equal is number 4, 2. Okay, then I go ahead and graph this. And this is how I can verify, yep, it's a parabola, then it goes up as a straight line. This is how I can verify that my sketch by hand is correct. Okay, so part A C graph right there, and calculator. Check. So let's go on to part B. Part B is saying let h of x equal to f of x minus 1. Okay? Using what you know about shifting, sketch the graph of h of x on top of the grid using a different color. So let me go ahead and write h of x in green. Okay? So I'm going to sketch h of x in green, and I know h of x is just going to be f of x, but what this is doing, x minus 1 in the input, is shifting it to the right. Shifted right 1 unit. Okay? So again, I'm going to just look at exactly f of x here in blue, and h of x is going to be, here, let me even write, this is f of x. So for h of x here, I'm going to draw it in green. Okay, so every point is shifted to the right, including all of these, right? Every point. Okay, so this is h of x. Okay, so in green is h of x. Alright, so we graphed it, we shifted 1 unit to the right, and we graphed it. Alright, so let's go to part C. Part C is for the function f of x, the transition point occurs at x equals to 2. Right, x equals to 2 is where there's a transition and we go from one graph to the other. Okay, I think we called it a fence in class once. Okay, so where does the transition point occur for the function h of x? So transition point of h of x. So the transition point of h of x, well, where are we going from the x squared parabola to the x plus 2 line that's been shifted over to the right? Well, before we were at 2, and now it's happening here at 3, right? At x is 3, we have this kind of fence there. We don't need to draw in the fence. We can see at x is equal to 3, that's where the transition happens. Okay? At x is equal to 3. Alright, let's go on to part D. Part D says find the piecewise function for h of x. Write the function in the space provided on the page. Use your calculator to verify your expression. Okay, so I know h of x is equal to f of x minus 1, right? We defined it right here to be that. So I'm going to plug this in to f of x. Alright? So f of x we know is x squared, but now we have the input being x minus 1, so it's going to be x minus 1 squared, or, right, it's going to be x plus 2. So instead of x plus 2, it's going to be x minus 1 plus 2, right? And before we had 4, x is less than 2. Well, now it's going to be x minus 1 is less than 2. And before we had for x is greater than or equal to, so now it's going to be x minus 1 is greater than or equal to 2. Okay? So let's simplify this. So that's equal to, I'm going to leave this as x minus 1 squared, because it just looks like x squared shifted to the right by 1, and that's what we want it to look like. But I'm going to simplify this. X minus 1 plus 2 is just x plus 2, because we combine the negative 1 and the positive 2. Okay? I got 4 right here. So I'm going to say 4, and now I'm going to solve this equation for x, right? So I'm going to add 1 to both sides, and that's going to get me x is less than 3. So I'm going to change this here to be for x is less than 3. Again, here, I'm going to solve this one, so I'm going to add 1 to both sides, and it's going to make it x is greater than or equal to 3. So for here, I'm going to say for x is greater than or equal to 3. So now I'm going to plug this in here, and I'm going to say h of x is equal to x minus 1 squared for x is less than 3. I'm copying it just as is right here, and x plus 2 or x is greater than or equal to 3. Okay? And let's go ahead and look. That's how we define it to be. And then let's use our calculator to check. So bring out your calculator. Go ahead and y equals. And now I want to go ahead and change it. So let me clear. And first, again, I want to plug in x minus 1 squared in parentheses. So I'm going to use a double set of parentheses to put x minus 1 in there and square it, right? So that's going to put the whole thing in parentheses. Open it up and say x is less than, second math, less than number 5, 3, close the parentheses, plus x plus 2 in parentheses. Open up the parentheses and say x is greater than or equal to 3. Graph this, and let's see if it matches. Yep, this is just shifted to the right, and it looks like it matches. Alright, so go ahead and say over here, graphed in calculator, matches. Check. Okay, so now this is going to end our problem, right? We've done all the steps, and that's end CPM Precalculus, Chapter 2, number 17.